All right, so I open up the review just so we can talk about a couple of things as we go through. Obviously, notice the ones that say, some of them say calculator active, like this guy says calculator active. If it doesn't say it, all right, so all of them except for 28 and 29 say calculator active if they are. If not, then you're doing these without a calculator. So make sure that you complete them as such. So in the beginning, you're just looking for your inverse functions. I would say, I'm going to give you back your quizzes today, but I would say a couple of things to pay attention to is make sure that you do the negative ones. So if it's h of x, the answer needs to be h negative 1 of x. And then there's two different types. One where it starts exponential and you go to log, and one where it starts log and goes to exponential. Be prepared for either of those. This would be an open-ended kind of question. 2? I think 2. And then comes the graph. So these are your graphs. Remember, we did this also on the quiz where it's a loosely based graph, but you're going to talk about your translations. You're going to have to answer the asymptote, domain, range, the end behavior, and then the graph. For end behavior, be careful which direction it's coming towards your asymptote. So I would say, again, I'll give you back your quizzes, but some of you, instead of putting plus, put minus, or minus instead of plus. If it's coming from the right, it's on the right-hand side, then it's plus, and if it's coming from the left, it's a minus. When you get to something like 7, so 7 came after your quiz. It says, what are all the solutions to the inequality? So the first thing you're going to do is condense that down, and then it's a one-to-one, so we can ignore the logs, we're going to solve it. But these are the ones you have to remember have a domain restriction, even though they don't mention it, right? What's the restriction on something like this? On any log? Good. So whatever's next to it has to be bigger than 0. So before you even start these questions, make sure you do this. So it has to be greater than 0. This has to be greater than 0. Anything with a variable has to be greater than 0. And then when you get your answer, you make sure that's your lower bound. So whichever one of those is bigger, or is a bigger number. So if it said x is greater than negative 3 and then x is greater than 4, I'm using the 4. So if you need to draw yourself a number line, whatever you need to do, don't forget about that restriction. So I think there's multiple choice and open-ended on something like that. But you have to think about it. One is using the calculator, one's not. You have to make sure that you check for that domain restriction. Same thing with this one, okay? So there's a domain restriction there as well. Question, if I put this in my graph, one's here, and then one, was it underneath it? No, it was above it, and then it goes under it. Something like that, right? So I want, in the initial question, I want where it is less than it. So the blue, let's say the blue was this one, and the red is this one. So my original question, I would want from this point, from this point to positive infinity. That's the right answer, okay? Which is C. But if that was switched, if this question changed to be greater than, now I'm looking for this part of my graph here, right? But there's a limitation. It's not negative. It's not A. It's not negative infinity to negative 1. There's a restriction on this graph because it's got a vertical asymptote. Does that make sense? And it would be from where my vertical asymptote is, which is at negative 2, to negative 1. So you have to make sure you pay attention to things like that, like negative 2 to negative 1 would be the answer if it said greater than. Because you have to stop your graph at your vertical asymptote. This graph does not keep going to negative infinity. It turns up, right? Because there's a vertical asymptote, and my vertical asymptote is at negative 2. Does that make sense? Okay. So that answer as it is was C, and you didn't have to worry about your domain restriction. But if it was reversed, it would totally change that question. So we're expanding and condensing here. Here we're here we're expanding. Here you're condensing. That was also from your quiz. Here we're expanding and then finding the information out about the graph. You're solving these equations. These are the ones you have to check to rule out any extraneous roots, right? Like if I end up with something like x is negative 1 and I go to plug it back in here, you cannot use it. Even a positive one, you wouldn't be able to use there. So you have to check for stuff like that. And then on the bottom, this is where you're going to find the intersection of those 2 points. So you can graph a y equals this first one, graph a y equals the second one, and you're looking for where they cross. You're looking for the x values in these. So like that's what typically you'd be looking for. That one AP question was weird that they looked for the y. These you'd be looking for the x values. This one is calculator active. And then comes all the calculator stuff like where you're building your regression model. So 28, it's asking you for a regression model for exponential. 29, it's asking you for a log regression. And then it happens again 32 where your calculator comes back in. And for this one, this is the one where you have to figure out the log values and you have to figure out your linear regression. So that's kind of what we did in 214. And then the semi-log plots are there at the top. Not 214, sorry. We did that in 215. And then this where you have to fill in your log. So all that stuff is like heavy calculator active. The other thing I would say you want to make sure you review is your formulas for half-life, double life, continuous, although usually they give that one to you. It's like 28 is an example of continuous that's already given it to you. So what's the formula for half-life? Initial. 1/2. T over the number of years or time, right? Which is H. Days, years, months. Until half. And then the only thing that changes for double life is that 1/2 becomes a 2. Like whatever it is. So if it says bacteria grows and it decays and its half-life is 30 days, then H, or it would be T over 30. Right. Unless it was different, like I gave it to you in days and it wanted it in months, it wouldn't do that because different months have different days. But like weeks maybe, then you'd have to worry about that. But it's not going to do that this time. So it could say something like the double life is 10 weeks. So it'd be T over 10. Yep. If the question is how many weeks, right? So like that's, the unit should be the same. And then continuous is your PERT, where P is the initial, E is your natural base, R has to be in, good. So if it gives it to you in percent, we move it back. And then T is however long that's in. And these could be asked, I would say the biggest trick here is, am I plugging in or am I setting equal to, right? Like you have to figure out which of those they are. So if it says how much remains after blank amount of time, you're plugging in and you're doing just the right side of your equation. If it says how long will it take for it to hit this, now you're setting it equal to that value. And if it says in what month or on what day or any of those, that's when you round up. So if it just says how long does it take, decimals. If it says during what month, on what day, like that, that's when you have to give a whole number. Or how many months have passed. Like those things you have to pay attention to, okay? Because that's when you'll have to round, and you always round up in those cases. Does that make sense? Yes? Okay. All right, the solutions are posted too. I want you to work because obviously this is tomorrow, and if you haven't started it yet, it's crunch time, people. Yeah.